don't have to like hold it down and then press it. You just tap it.
I do because I have to make sure the mic is on.
Is it not already on? Like
It doesn't always stay on, so I have to make sure it's on. Alright, so this is... I learned my lesson last year when one of them didn't have any sound. It was very sad. Alright. Representing, and I didn't know it until I posted the video because it was one day that I didn't check the sound. And the person came back to class and said, there was no sound, but I took the notes anyways. Great. Representing relations and functions. Alright, so assuming you watched the notes videos as you were supposed to, what were the 4 ways to represent relations?
graph, table, mapping, and ordered pairs.
Okay, and what was the test to determine if a relation is a function?
Vertical line test.
Vertical line test. Okay, good. That's all stuff we're going to use. Alright, so we're going to start with number 6. Okay, these ones say to identify the domain and range of the given relation, then represent the relation using a graph and a mapping diagram. Okay, so I'm going to copy down all the points that are listed. So, -7, 4, 2, -5, 1, -2, and -3, 6. Alright, so it wants domain and range, and then it wants a graph, and then it wants our mapping diagram, okay, which is the input-output table. So, what are my domain values?
-7, 2, 1, -3.
And range?
4, -5, -2, 6.
Okay, and I don't remember if this was covered in the notes video or not. If, let's say, this point instead of -3, 6 was -7, 6, what would be different about my domain?
You wouldn't put the -7 twice.
Yep, exactly. I would not put it twice. I would only put it the one time. Alright, so that's the first part, and then it says to do it using a graph.
It's like the worst part about it. I would rather not, but that's not an option.
Alright, so then you're just going to plot each point starting with -7, 4. And unless you just are dying to use graph paper, this isn't something that I care about you graphing on graph paper. Let's see, 2, -5. 1, -2, and -3, 6. Alright, and then it wants a mapping diagram, okay, which is going to be our input-output table.
Easy.
Okay, you have to label these. So your inputs are all of the x values, okay, and the outputs all the y values. Now, what I'm going to tell you is it is not acceptable for you to say, I'm just not going to write the domain and range, and I'm just going to write over here that this is the domain and this is the range. It asks you for 3 things. You're going to show all 3 things, okay? I do take points off for that, and I say, you're missing this part, okay? You have to write input, output. That is the proper labels for this mapping diagram, okay? I'm just saying all these things because these are things that last year, it didn't matter how many times I said them, people still didn't do them, okay? Don't do that. Don't fail me, please. Okay. The other thing is write the numbers in order. Okay, smallest to largest as you go down. Don't write any repeats. Okay, so -7, -3, 1, 2, and circle them or oval them or something. And then your output values -5, -2, 4, 6. Do the same with them. Okay, and then you match them up to what they go with. Okay, if there was a number that was repeated, it's going to obviously get used twice on either, in either case. We'll do some in a minute where there's repeated ones. But for right now, we have -7, 4, so we match up -7 with 4. -3, -3 goes with 6. 1 goes with -2. And 2 goes with -5.
Mine are just straight lines across because I didn't have nothing.
Okay, so based on what we did in the notes, would this actually be a function?
Yes,
Why?
because there's only one thing connecting to each other.
Okay, each input has exactly one output. All right, then moving on. Okay, I'm going to copy them over in the book. I swear I just thought I saw a bug. These ones say to tell whether the relation is a function and explain. You don't have to copy over the tables out of your book unless you just want to. I'm going to copy them down just so that they're in here for example purposes. But I don't care that much about if you actually copy them over as long as you explain your answer. All right, so this one we have -6, -4, -1, 2, 5, 2, 1, -1. So obviously they didn't write them in proper order, but that's okay. All right, and then their matchups that they gave us are just straight across. All right, so is this one a function?
Yeah.
Yes.
Why?
Because of integrated and yeah.
It's a function. Each input has one output.
Does that say F not? Like,
No, FNCT for function.
So if it is a function, do we write it? Do we put that in the answer that it is a function, even if
It asks if it's a function or not. So you're going to say
Oh.
function or not a function. And then you're going to say each input has exactly one output or the opposite if it's not true. So then like number 12, we've got, let's see, -1 and 5, and 4, 2, -1, -3. And then they have -1 going to 2 and -1, and then 5 going to 4 and -3. Is this a function? Why not?
because the input has more than one output.
Alright, I'm gonna do one more example just so we see it. It's not one in the book. -3, -2, 1, 4, and then 3, 2, 4. Actually, I might have pulled this one from another page, 'cause I wouldn't have written them that way. It's okay. Alright, so these matchups would be -3 to 2, -2 to 3, 1 to 2, and 4 to 4. Also, I don't know why I wrote function on the other one on 12. It's supposed to be not a function. I said it, I just somehow didn't write it apparently. So with this one, is this a function?
Yeah.
Okay. The reason I go over this one, okay, is because sometimes people see that the output has two things like connected to it, okay? They're coming from two different inputs, which is why it's okay. But some people see, oh, there's two things, and then they correlate that to mean that, oh, it's not a function. That's only affected by the input. The outputs do not affect if it's a function or not. Okay. Let's see. All right, so the next ones say to tell whether the relation is a function and to explain. So we're given ordered pairs in this case. So we're given 0, 1, 1, 0, 2, 3, 3, 2, and 4, 4. All right, so is this a function or not?
It's a function, yes.
Why?
Because each input.
Okay, yes.
I just say one
Each input has one output. Okay, if you wanted to check it, okay, it doesn't tell you have to do it this way by any means, but if you wanted to verify, or if you're like, I just want to check myself and make sure that I know what I'm talking about, you can always go down and draw your mapping diagram. Okay, and then connect 0 to 1, 1 to 0, 2 to 3, 3 to 2, and 4 to 4. Okay, and then you could verify it that way. You don't have to do that, but that would be another way to explain your reasoning on that one, just FYI. All right, with 21 through 23, okay, I'm going to draw them on my paper. They're already drawn for you in the book. It says to use the vertical line test to tell whether the relation is a function. So 22, you're given a graph that is something like that. Do y'all know what direction a vertical line is? Just checking. Okay, just checking. I mix them up all the time, so I'm just making sure. Okay, so this is as simple as taking your pencil and laying it down and going across, and if at any point it hits twice, it's not a function. Okay? So I'm going across. In no place does it hit twice, so it is a function.
It's a function. You know, is that even possible? Like, how do you get to squiggle?
I just did this, basically.
Yeah, but like
Like,
with
what
numbers,
points
like
it-
in,
yeah,
with
like-
real numbers, could that actually?
Oh, yes, there are functions that graph stuff like this.
Ew. I don't think I want that. Yeah, I like straight lines.
I don't like the, what do they call it, parabolas or something?
Oh, you don't like parabolas?
No, dude.
Well, there's a whole chapter on those in this
We
class.
kinda went over it a little bit in algebra, but like not really at all.
Yeah, because I think that was at the end of the year y'all had that would have been the very end. And that was one of those things that was complicated. And I'm pretty sure I told my mom, I was like, yeah, just don't worry about it too much. They'll get it with me in Algebra 2.
Maybe we'll get more of an understanding.
We do a lot more with them in Algebra 2. We like answer questions and use them to help solve things.
Okay.
But yeah, we use them a lot more. All right, I'm just going to do other examples not in the book. Let's see.
Oh my gosh.
What is that?
Well, it's not a function.
Okay, as I drag my pencil across, okay, it hits in multiple places.
Yeah.
3 times.
Okay, it is possible to get a graph like this. It is very possible to get a graph like this.
Ow.
It shouldn't.
Okay,
It shouldn't be possible.
It looks like that.
just letting you know it is possible.
Oh.
But this is not a function.
Yeah.
That's like no function. That's no function.
No function.
Another one.
Has no function.
I don't like how much space graphs is on paper. That's the issue I have. I'm just so
That's
what?
possible
That's not.
too.
Oh, we've had circles.
You
huh?
can't graph a circle?
Yeah, we've graphed.
Or like an
circles.
ellipse or...
We've done that in
I don't
geometry.
think
We had
we
to
have
draw.
Peyton.
No, we had to draw a circle on a graph in geometry. I know
Would you like
that.
me to make it a better circle?
We had to use like a compass. I remember doing it. No.
What type of
Wow.
witchcraft did I do?
Beautiful.
Crap.
Or
It's
something.
okay. The tablet auto corrected it for her. I swear.
Oh, okay.
We're living in a
that's not
simulation.
function either.
I saw it happen.
What is that?
It's a simulation.
Oh! Oh. I just didn't woke up quick enough to see that.
It's Monday, I can't.
I have to have a little fun with it, right?
Not like
Alright, so as I go across, we hit in more than one point, so it's not a function.
That doesn't look like math. That looks like symbols.
Can you
You're
draw
not
like
drawing.
a perfect circle on the board?
Right?
No.
Then I there's some people that can just like go like
I
that.
could do it like behind. Yeah, no, I can't do that.
like the.
I also don't write on the board that often, so
Yeah, it doesn't look
certainly
like
couldn't do it right
I
now.
could do it. Just.
I can do it on my tablet.
Oh yeah. You
Mrs.
can.
Marshall said she had a teacher that would literally stand like this and behind her just draw a perfect circle. And I'm like,
Mr. Cass is pretty good at it. If he's well, I don't know if he used to be pretty good at it. I assume he still can, but since he hasn't written on a board in a long time, it might be a little harder. But if you have him, you can ask him if he can do the perfect circle at all. Also, probably get him off topic for a little while. Just heads up. Totally fine. Just
That's
letting
what
you know.
we want.
we did the whole like unknown thing with figures or whatever.
I know.
We're like, oh,
We went
class
really
period.
off topic.
With the
Five,
fine.
figure,
Yeah.
whatever.
Oh, not that color. Go away.
Like what? We're not even learning this one. What is?
All right. The next thing says for 34 through 39, tell whether the function is linear. Okay, what does that mean?
Straight.
It's a line, okay? Last year, these poor people told me that parabolas were linear. They are not.
Well,
What?
'cause they're
Okay,
not
if x is squared or square rooted or anything, it can't be linear.
Okay.
Okay?
'Cause that's
Please
not
don't
a
make me
line.
sad.
That's not a line. That's
Exactly. But some people said it was linear.
a.
So, please don't make me sad.
Okay.
Please know that
Jake's gonna
to be linear, it has to be a line. Okay?
It is a line, just not straight.
All right, and then it says evaluate the function for the given value of x. So you first tell if it's linear or not, and then you evaluate. If it's not linear, you still evaluate. Okay?
Okay.
So it's a two-part problem.
I need to
34.
keep these done.
F of x is equal to x plus 15. And we're going to do this for f of 8. Okay, that means, in case you're not familiar with this notation, I don't remember if this is the first time you've seen this or
I was
not.
all on that pre-test thing.
Yeah,
Okay.
Yeah,
we had no
I
idea
didn't know
what
what to do with it.
Okay,
I
so this
did.
just
I
means
did.
plug this value in for x.
Yeah.
Okay, whatever's in the parentheses goes in for x is all that means.
Yeah.
All right, but my first question is this linear?
It is.
Yeah.
Okay, it is linear. It's in y equals mx plus b. Okay, if you wanted some proof, you could, graph it. I'm just gonna make that 15.
Yeah, no thanks.
And then, you can do the whole whee, it's a line. Or you can just take my word for it. All right, so now we need to check and see what the value is. So I'm going to say f of 8 is equal to 8 plus 15. Okay, it literally just gets plugged in. So what is that, 23? So the answer is linear, and the answer is 23.
Oh,
They're real hard.
that's all.
Yeah.
I
Yep.
have to do on that.
You don't even have to graph them. I purely just did, just for the fun of
Yeah,
it.
it was actually a really easy
Well, I
All right.
have question marks.
F of x is equal to the absolute value of x plus 10. F of negative 4 is the value that we're solving for. Is this linear?
No.
Why not?
I don't know.
Do y'all know what a graph of an absolute value looks like?
Positive,
No.
right? I don't know.
Well,
Do you not take it
It
out?
does. It doesn't look like a line. Does that?
Do you not solve the outcome?
so in this case, okay, I'm counting by, whatever. In this case, this one is, okay, it's shifted up 10. That's why I'm putting it up here. It's a V.
No.
Why not?
Because you have to account for the positive and negative values that it outputs. So if you put in a negative, if you put in a negative 1, it's going to come out as a positive 1. You put in a positive 1, it comes out positive 1.
Oh, 'cause they have to-
So it's 2 lines, but they're technically all one function. It makes a V.
Oh, so that means no. Not
Correct. Not a linear. Not linear.
It doesn't exist.
That makes sense.
And then f of negative 4 is equal to the absolute value of negative 4 plus 10. Okay, so the negative 4 inside the absolute value becomes positive. So 4 plus 10, so 14. So it's not linear, and the answer is 14. All right, last one. Please don't hate me. G of x equals x cubed minus 2x squared plus 5x minus 8, because it doesn't matter what letter I put there.
Maybe it should.
And g of negative 5. If it really offends you, you can make it an F.
I
don't care.
will. Actually, no. I
Why
already
there's
wrote down
so
G,
many-
and I'm using that, so never mind. That's a lot of numbers.
I don't know what it says on this kind of thing.
All right, I'm just going to tell you what this graph would look like.
Right?
Okay, this graph would look something ballpark like
It's not linear.
Why?
that.
Oh, so it can be squiggly.
Why would it look
Ah.
like that though?
The
Because
cube
it has
part.
depression patent.
Oh,
The cube part of it makes it do that.
No, it has depression.
Okay, Josh.
Because if you think about what values you plug in, like if you plug in negative 1 and cube it, you're still going to get negative 1. And so that's what causes it to. You can literally, just by doing negative 1, 0, and 1, you can get the curve that it's going to have.
Oh, that's
Huh.
huh. I don't want to do that, so I'm not gonna talk.
I'm not expecting y'all to graph these like when you do them. I'm just showing you more for fun what they look like. Okay, so I think everybody agreed this was not linear, correct?
Yes.
Yeah.
Okay, good.
Oh, I thought it was.
All right, and then we're going to plug in, I'm going to move down here because I'm going to need a lot of space. G of negative 5 is equal to, remember because it's negative and we're doing different powers, I would make sure you keep that stuff in parentheses.
Minus
What is negative 5 cubed?
125. Negative 125.
Negative 125.
Yep. Mhm.
Negative 5 squared
Negative 20, I mean positive 25.
times negative 2.
Negative 50.
That's
5 times negative 5.
negative 25.
Then minus 8. And then now you can just put all this together. Negative 125 minus 50. Negative 175.
So it was negative 208.
Negative 208. And that's it.
Number.
Cool.
Cool.
Yeah.
Well,
Not too hard,
it's
right?
math, but
Yeah.
so it's not cool, but.
Well, yeah.
All right, your problems are 5, 11, 17, 21, and 35.